Hi guys, we're gonna do module 3, lesson 5 today. Okay, and so the objective for this lesson is today we will be multiplying multiples of 10, 100, and 1000 by single digit numbers. Okay, so we are gonna be looking first at some review words that we need to review that will be important for our lesson, and make sure that you're paying very close attention to the strategies that we're using for this lesson, because you are going to be expected to use those strategies doing your independent work today. The first keyword that I want to review is the word unit form. Okay, so when we were back in module 1, we were talking about standard form, expanded form, word form, and unit form. So the unit form is when we write the number along with the place value unit. So if we were talking about 50, instead of writing 50, we would write 5 tens. Or if we were talking about 600, we would write 6 hundreds. Unit form is very important for this lesson in making sure that we understand all of the place value involved with multiplying multiple digit numbers. The next word I want to talk about is the word decompose. The word decompose we talked about last lesson. So when we decomposed a problem, such as 4 times 30, we took the 30 apart and broke it into 2 pieces. So we broke the 30 into 3 times 10. So our new problem looks like this: 4 times 3 times 10. This makes it easier for us to multiply, because a number multiplied by 10 is much easier for us to think about than 4 multiplied by 30. So when you multiply 4 and 3, both single digit numbers, you end up with 12. And then we are going to multiply again. We're just going to bring down our 10. We're going to multiply by 10 again. Okay. And 12 times 10 is easier to think about than 4 times 30. So 4 times 30 is more complex than 12 times 10 is, which is, we know 12 times 10 is 120. So when we're decomposing numbers, this is exactly what we're doing. We're breaking the numbers down, or we're breaking down the problem. Okay, so our first problem is going to be 2 ones times 4. So first, I want you to represent that in your place value chart. So if you don't have your place value chart, you need to go get your place value chart. And if you do have your place value chart in front of you, you need to represent 2 ones times 4 in your place value chart. Okay, so I'm going to change to blue. So when we represent 2 ones times 4, we're going to represent 4 groups of 2 ones each. And actually, okay, so you can do it that way, or you can do it up and down, whatever way you would like. Okay, so 2 ones times 4 is going to be 8 ones. Okay. So now what I want you to do is I want you to pause the video, and I want you to represent 2 ones, nope, 2, I want you to represent 2 tens times 4. What's that going to get us? Okay, so 2 tens, if we're representing 2 tens times 4, which I'm going to write this one up and down, we end up with 2, 4, 6, 8, 8 Okay, so here I've also represented 200s times 4. Okay, so 200s times 4. And the 200s times 4, we're going to compare to the 2 1s times 4 and the 2 10s times 4. So what I want you to do is I want you to stop the video and think about what the similarities are between these problems and what the differences are between these problems. What similarities do you see between the problems? So when I look at these problems, I see that in each problem, we have the same amount of units in each place value chart. We end up with 8 units in each place value chart, regardless of the place that it's in. So when we're representing 200s times 4, we end up with 800s, and 2 10s times 4, we end up with 8 10s, and 2 1s times 4, we end up with 8 1s. Okay, they're almost all exactly the same. We're just using discs in different columns. Okay, so our answer is going to be bigger in this one because our place value discs are in the higher column. Okay, what do you think is going to happen when we multiply 200s or 2,000s times 4? What do you think is going to happen when we do 2,000s times 4? Okay, so see my pattern. We have ones and ones and tens and tens and hundreds. So this one we can only assume would be 8,000s, which we would represent in the thousands column. Okay, let's try another one. Here I've represented 8 times 2, or 8 times 2 1s. So what I want you to do on your place value chart is I want you to represent the next 3 questions. I want you to represent 8 times 20, 8 times 200, and 8 times 2,000. Okay, so I represented all 4 of these problems together, and I used our unit form to represent them. So we started with 8 times 2, which in turn in unit form would be 8 times 2 1s, okay? And then that is equal to 16 1s, which is equal to 16. 8 times 20 is equal to 8 times 2 10s, which is equal to 16 10s, which is equal to 160. 8 times 200 would be 8 times 200s, which gives us 1600s, which gives us 1600. And finally, 8 times 2000 is equal to 8 times 2000s, which is equal to 16,000s, which is equal to 16,000. So think about all of the similarities and differences that you see in these 4 problems. What would happen? Let's look at our 8 times 200. Okay, what would happen if we instead wanted to do 800s times 2? Represent this problem in your place value chart and tell how it is similar and how it is different. So really, nothing is changing except for the way we're representing this number. Okay, it is important to note that just because our number would be 800 times 2 versus 200 times 8, they're going to be the exact same answer, because if we decompose both of these numbers, we end up with the same problems. So let's try that. Let's decompose this one. So looking at both of our decomposed problems, they have the same numbers in the problems. They're just in a little bit different order. But we know about multiplication is that you can move the numbers whichever way you want and put them in any order that you want to, and you're still going to get the same answer. Okay, now I want you to multiply these 4 problems in unit form. You can use your place value chart if you really need it, but I really want you to think about how to write these problems out in unit form. So on your whiteboard, you need to answer these 4 problems in unit form. Okay, so the first one is going to be 4 times 3 ones is equal to 12 ones, which is equal to 12. 4 times 3 tens is equal to 12 tens. It's equal to 120. 4 times 3 hundreds is equal to 12 hundreds. It's equal to 1,200. And 4 times 3 thousands is equal to 12 thousands, which is equal to 12,000. Okay, now look at our answers versus our questions. What patterns do you see? So I noticed that when a number has ones for its unit form, there are no zeros after our digits. So ones give us no zeros at the end of any digit. Okay, so when we're talking about tens, we have 1 0 in our tens multiple, our multiple of tens, and 1 digit in our answer, or 1 0 digit in our answer. Okay, for this one, I see 2 zeros. You see the relationship? And that goes with hundreds. So if we have hundreds, our answer should have 2 zeros at the end. Okay, and then the same with thousands for 3 zeros. How many zeros do you think 10,000s would have? What about 100,000s? I wonder if this pattern works every time. Okay, let's try this problem. Go ahead and try this one on your own. Okay, look at the pattern and see if it is the case. See if that's the case, that it works every time. For For the first question, we would have 5 times 2 ones, which gives us 10 ones, which gives us 10. Tens. Now with this problem, we have seems an extra 0 here. Why do you think that is? In our previous problem, we talked about tens and how we would have 1 0 and 1 0. But this one has 2 zeros. Think about, why do you think that's the case? The reason why this happens is because 5 times 2 is 10. So that's where our extra 0 is coming from, that 0 from the 10. So the pattern still works, right? We still have 3 and 3 for thousands, 2 and 2 for hundreds, 1 and 1 for tens, and nothing for ones. Okay, so the pattern does work every time. Okay, let's solve this problem. Francisco played a video game and earned 60 points for every coin that he collected. He collected 7 coins. How many points did he earn for the coins he collected? We need to first draw a picture, because we always need to draw. We're going to read, draw, and write. Those are our steps for problem solving. So a good picture we could draw is actually a tape diagram for this problem. So we're going to represent the 7 coins that he that he collected in our tape. Okay, so here are 7 coins that he collected. If each coin was 60 points, and we have 7 even coins, this whole tape is going to be our total. That's going to be how many points he collected. Okay, each box is a coin, so each box is worth 60 points. Okay, so the way we can solve this problem is by multiplying 60 times 7. Okay, there's 2 different ways that we talked about how we could solve this. Okay, we can decompose these numbers like we did in the previous lesson and a little bit in this lesson, or we can multiply using our unit form. I'm going to represent both ways. You go ahead and solve it your way and then unpause the video. Okay, So here are both of my solutions. In A, I did unit form and I did 6 tens times 7 is equal to 42 tens, which is equal to 420, because I know that 6 times 7 is 42. So 6 tens times 7 would very easily be 42 tens. Okay. For B, I decomposed my number. I broke 60 into 6 and 10. Actually, I broke 60 into 6 and 10, and I brought down my 7. Okay. And then I rearranged my numbers so that my 6 and my 7 were together, because those are the two numbers that are more difficult to work with. Okay, so I just isolated the 10 by itself, and I knew 6 times 7 was 42. And then I brought down my 10, so then I had 42 times 10 and multiplied that together and got 420. Okay, so when you're doing your practice assignments today, if there is a place value chart, please try to use your place value chart to represent your multiplication. Okay, if it asks you specifically to do your multiplication problem in unit form, please make sure that you are doing exactly what the question's asking you. Okay, each of the questions prompt you by giving you blanks for the things that you need to provide to fully answer the question. Okay.